Hello all. So as a continuation of my lecture series in power system analysis, we had a small introduction video in the previous video. So now we will go into per unit system in which uh, we will have a just introduction about the power system where it consists of generating stations, transmission lines and distribution systems. And this generating station and distribution system are connected through transmission lines which also connects one power system to the grid. A distribution system connects all the loads in a particular area to the transmission lines. So this is what is a single line diagram which is very important in analysis. So single line diagram, we will be having a generating station where they will generate 11 kV and that will be transferred to the primary transmission and secondary transmission. Similar way we will be having primary distribution and secondary distribution. So while transmitting, we will be using a step up transformer in order to avoid the transmission losses. So that that voltage will be again step down in the distribution side like 33 to 11 or 66 to 11 kV. So in primary distribution, we will separate industrial consumers and after that 11 kV will be again step down to 415 or 230 volt as single phase and three phase consumers based on the demand. So this is the representation of the transmission system in a single line diagram. Coming to per unit, so what is per unit is, in all the manufacturers will define the value in per units, so which is very important. So here key problem in analyzing power system is the large number of transformers. So it would be very difficult to continually having a refer impedances to the different sides of transformer. So this problem is avoided by normalizing all the variables in per unit. So this is what is per unit quantity. So general per unit can be determined by the formula actual value by base value. So per unit in kV is actual kV by base kV. So if it is for impedance, we can write it as actual impedance by base impedance. So if we for reactance, so the similar way we can change the formula to reactance. So what are all the advantages and uniqueness of per unit system is, the per unit values of transformer, impedance, voltage and current are identical when referred to primary and secondary. So no need of reflect impedances from one side to other. So the transformer is a single impedance. A per unit value of various components lie within a narrow range regardless of the equipment rating. So the per unit value clearly represent the relative values of the circuit quantities and many of the scaling constants are eliminated. So that's why we are going for per unit system. So coming to procedure for per unit conversion, first we have to pick a single phase VA base for the entire system. So we have to first choose the base value and that voltage base of each different voltage level, and voltage bases are related by transformer turns ratios and voltages are line to neutral. Now we can calculate the impedance base ZB is equal to kV whole square by MVAB, which is for the entire system. So that calculate the current base. So I is equal to V by Z and convert actual values to per unit values. So this per unit conversion on affect magnitudes, not the angles, and also per unit quantities are no longer have the units. So it will have, we mentioned like 1 per unit. It is not like 1 per unit volts. It is only per unit. So this is the general conversion of per unit. So here we have a problem, a three-phase generator with rating 1000 kVA, 33 kV has its armature resistance and synchronous reactance as 20 ohms and 70 ohms per phase. So calculate per unit impedance. So here we have to frame the formula like per unit impedance is equal to actual impedance by base. So actual is It's given in the problem like 20 plus J70. So that can be written as 20 plus J70. And in the base value, the 1000 kVA to be converted to MVA, where we have to divide the kVA by 1000. So by using these values, we can find out the per unit impedance of the generator. We will solve the problem in the next video. Thank you.